Hi and welcome to Cherry Pie Math. This video is going to go over something called sampling, drawing lots of different samples from a couple of different surveys. Before we get started, you do need to know what a mean is or how to find the average. So let's take, for example, a book. Just find a random book and I want you to just find the mean number of letters in 10 words and then do it again and again and again. Try it a couple different times. You'll probably notice that the mean number of words changes from each time, right? So based on your results, I want you to think about what do you think is the actual mean number of letters in a word in the entire book. And that's the concept behind sampling, is you're basically doing a little survey lots of different times and then using those results to compare against each other to try what's called the true mean, especially when you have such a large sample in the first place that it's going to be impossible to go over them all. So for larger scale surveys, so like common surveys, you'll usually just find one measure of center, call it good. Like let's say you want to find I want to find the average height of the people in my class. You can just ask everybody and call it good. But when you're dealing with a larger population like a city or an entire country, you can't, that's impossible to do. So you basically do the same survey lots of different times and compare the results and then find the average of those results. And that's what you would call the true measure of center, as close as you can. There's a little bit more math behind it, but that's basically the basic concept, is you do it lots of times and find the average among the averages. So let's do, for example, let's say we have a jar of candy and we have some red candies and some green candies. Ignore the picture. It was just a picture of candy that I could find. But we want to find the percentage of red candies that exists. And so it's a huge jar and I just take out 5 at a time and then I see how many red candies I have and how many were green candies. So let's give it a shot. So let's find the percentages. The first one is going to be 40%, and then it'll be 80%, and then 80%, and 100%, 80%, 100%, 80%, 20%, 60%, and 100%. A really quick tip, actually, if you're curious about how I think this is fast, when it's out of 5, like if you have a fraction and it's out of 5, you just multiply the top number by 2 and then add a 0. So 2 times 2 is 4, 40, or 5 times 2 is 10, add a 0 and it becomes 100%. Anyway, that's just kind of a quick tip if you wanted to know it. And then if I wanted to find the mean, I'm going to add all of them together and divide it by the number of data points I have, which in this case is 10, because I'm not doing the number of candies, I'm doing the number of trials, because I'm comparing the results of the trials. So let's see, I have 40 plus 80 plus 80 plus 100 plus 80 plus 100 plus 80 plus 20 plus 60 plus 100. Divide that by 10, and I get 74%. My median, I would have to arrange it from least to greatest. So I have 20 and then 60. Oh, sorry, not 60. 40, 60, 80, 80, 80, 80, and 100, and 100. I think that's 10 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I missed one. 2, 3, 4. Which one did I miss? Oh, I have 300%, so that's why. Okay, so then I just find the middle one. In this case, I actually have 2 in the middle, but you find the average between them, and since they're the same, it's just going to be 80%. The mode is whatever number appears the most amount of times. That is 80% as well. So based on this information, I want you to think about which one, or what do you think is the actual percentage of red candies in this jar? So some people might use the mean. They might say 74%, and others might say 80%. The actual mean that I had in mind when I did this trial was 80%. But as you can notice, they're pretty close. Like it's not terribly wrong to say the mean. But it's not 100% accurate. It's closer than it would be if I had just, taken the first trial and been like, oh, it's 40%. That's so far off. So sometimes the mean helps, sometimes it doesn't. But having those multiple trials did help us to narrow it down to see what is the most likely candidate to be our our measure of center. So this is useful on a larger scale because it helps to average out the variation, I guess we could say, because each trial you have is going to be always vary. I don't know. I have the worst luck. Like when I'm doing games, you know, like rolling dice is random, and somehow I always manage to get the wrong number that I don't like, a number that I don't want, even if it's the least likely to happen, even if I can have any number except for a 1, and then I roll a 1 anyway. Like it always happens to me. Or like my daughter always picks the wrong shoe. It's a random choice for her, but she always picks the wrong shoe to go on the foot. So it's just helpful because it settles out the variation, because there will be variation when you're doing different surveys. A major drawback to taking the mean is the potential for what we call outliers. And kind of like how the name suggests, outliers are data points that are far outside norm, that are far from normal. So for example, let's say we're looking at like shoe sizes. I have incredibly small feet. And so if you looked at my feet compared to like everyone in my in-laws family, my feet are going to be the smallest one. So if you're looking for the average, if you're looking for the mean, because you're adding in my shoe size, it is going to end up drawing the mean a little bit more to the less than what it should be. So that's where the median comes in handy. So outliers will often ignore, because like, yes, they are data points, but they're so rare and they're so far out there that we'll get a better picture if we just kind of ignore the outliers. So that's why we take the mean of multiple samples, because when we take the mean of multiple samples and then we take the average across those, like I said, it gets rid of that variation. We don't have to worry as much about outliers because we'll be able to settle it out with the other samples that we have. So some things to remember, measures of center will help tell the story of a data set, like mean, median, and mode, and it'll help us apply it, and we'll be able to say, oh, this is the measure of center, so this is what it means for my survey question. But different measures of center are useful in different scenarios. So like we saw, the median was actually more helpful in our experiment than the mean was, because it was less affected by that variation. And taking the mean of lots of samples means it can help us actually get to the actual population mean, so we can get that settled down to the variation. Okay, good luck.